Hello, everyone. Welcome to today's session of Televate Tech Talk. In a previous version of Televate Tech Talk, we discussed about how important it is for public safety agencies to thoroughly define their radio coverage requirements. One of the most important aspects and one of the more difficult aspects of these requirements is in-building radio design signal loss margins. And today, Televate's senior partner, Dom Arcuri, is going to investigate this key in building coverage topic. Dom, thank you for presenting this topic, and please share some of your thoughts on in building radio coverage.
Thank you, Rick, and hello, everyone. Yes, Rick, you're exactly right. The in-building radio design margin is a significant aspect to define when you're defining your radio requirements. The design margin is required to overcome the penetration loss of a building that the signal experiences when it passes through the outside wall or inside walls as well. The level of the design margin is important to define and correctly because it has a significant impact on the system design. It has an impact on the number of transmit and receive radio sites required to provide the required coverage. So, for example, if an agency requires a very high level of in-building design margin, that will require many more sites and will increase the cost of the system. It also impacts the types and number of buildings where reliable communications is possible without some type of individual building enhancement. And when I mean individual enhancement, something like an in-building system or a distributed antenna system, commonly referred to as a DAS. So the goal with defining the in-building design margin is to kind of strike a balance between those two considerations so that you don't over-design the macro system, include too many sites, for example, but you also try and minimize the number of buildings that would require some type of supplemental coverage.
So, with establishing that foundation, can you talk about how signal loss varies based on the type, structure, materials, exterior and interior of the building?
Yes, exactly. The types of materials, the building construction has a significant impact on the amount of signal loss experienced when your radio signal tries to penetrate a building. Certain types of construction or construction materials like drywall or plywood or simple glass have a minimal impact on the signal, but others that are more substantial, as you might guess, brick or concrete, masonry construction have more significant impact. We're showing a table here that gives an example of some of these anticipated signal attenuation levels for different types of materials. You might notice at the bottom is low E glass or efficient glass that's used a lot in modern construction for high thermal capability. That has a very significant impact on signal attenuation. And those buildings, for example, potential high-rise buildings with a lot of low E glass, be very, very difficult to get signal inside those. So we try and classify typically 3 levels of buildings. And these are somewhat broad, but we would refer to a light building as an example of a wood frame structure, for example, or the typical residential buildings. And those might experience a 10 to 15 decibel or dB level of attenuation or signal loss. A medium building might be something that you might see, for example, small stores or offices, maybe a strip mall, and that's going to have a little higher level of signal loss or attenuation, probably 15 to 20 dB. is the figure we might use for a design for in-building margin. And then finally, there are heavy construction buildings where there's a lot of masonry used in the construction. And that might be schools, courthouses, jails, and those can have a very significant impact, at least 20 to 30, and in many cases, more. Also, it's important to realize that the loss you'll experience of your signal will vary depending on where you are in the building. Obviously, we've all seen a lot of people tend to go towards the window with using their cell phone if they are having difficulty connecting. So if you're near the exterior, it's probably less signal loss and easier to communicate than if you are within the building and behind several walls that the signal has to penetrate. Also, the amount of signal attenuation varies by the frequency band. As you know, of course, public safety has access to various different frequency bands allocated by the FCC. VHF, or the 150 megahertz band, is typically harder to provide in-building coverage for. Those types of systems, the VHF signal has a long wavelength, and it's difficult to penetrate in buildings. And on the other end, the 700, 800 megahertz systems have less in-building penetration loss. So you also have to take that into account when designing your system.
So with the complexity of providing coverage to more difficult to cover buildings that have greater loss and attenuation, what are some key design factors that you would take into consideration when designing for higher loss buildings?
Well, that's exactly true. As we mentioned, if you need a higher level of in-building coverage, for example, if you were to design your entire service area to provide heavy in-building coverage, then you would need more sites, significantly more sites than if you were looking for light building coverage, for example, because the coverage footprint at a high in-building penetration level is going to be much smaller. We have an example figure here that shows different levels of coverage for a sample site. And you can see that the dark green shows the coverage footprint for heavy building penetration. The lighter green is a bit broader, and it shows coverage for what we might call a medium level building penetration. And then the yellow would be more of a light building penetration. You can see that's broader. And of course, the broadest of all of these is the red coverage area, and that's shown for no in-building penetration margin. So equivalent to having the radio outdoor in the street. Because of these considerations and the attempt to try and balance the system design and make it the most cost effective, a lot of times we will specify different levels of in-building coverage for the different areas of the service area. For example, if it's a county, there may be some higher building density areas in municipalities. And there we might want a higher level of in-building coverage, perhaps 20 or so. But throughout the rest of the county, it might be more open and more rural, and primarily have to worry about residential buildings. So we might have a lower level, perhaps 10 dB in that type of situation.
Well, every given market has buildings and different types of buildings. What strategies do you recommend for identifying the specific buildings that need to be covered, no matter what the attenuation value of those buildings?
Well, it's difficult to identify every building. You certainly don't want to have to test every building within a specific service area. So we try to identify those specific building levels, or the building signal penetration levels, as we mentioned earlier. But in addition to that, you may also want to identify some specific buildings, and you try and keep this somewhat limited, but the specific buildings that you absolutely need coverage. And that typically may be schools, for example, or the public safety building, the 911 office, or firehouses, courthouse, jail. These are the areas where you would expect typical public safety presence there, and you want to make sure you have those buildings covered. So you might specify those in your RFP, and that will tell the system designer that they will need to check to see at these locations how much in-building penetration they have, whether or not that might be sufficient. And if not, then they would plan for having some type of in-building enhancement for those specific buildings, like a distributed antenna system.
So it's as we say, and the industry says, public safety radio, reliable public safety radio coverage is king, including for in buildings. So agencies certainly need to take great care in specifying the required in-building coverage requirements, as you've indicated. So what additional advice do you have to offer to our audience to help them, guide them in both designing their networks and verifying coverage, and also keeping their finger on the pulse as new buildings are constructed within their operating environments?
Well, that's exactly right. They need to take great care in identifying these requirements. We would recommend that they research the types of buildings within their coverage area and the different areas, of course, where there's high density of buildings. And they may want to get advice on those types of buildings and what type of building design margin might be necessary. And also, they may want to consider testing some. If there's some specific buildings that are very important, as we mentioned, you may do some testing beforehand to try and get an idea of what the penetration loss is. And you can do that if you have an existing system of the frequency band that you're looking to implement, you can do that. Or if you don't have a system installed, you can still do some testing by using some equipment and actually putting the equipment inside the building and then testing outside, for example, to see what the penetration loss is. And once your system is built and implemented, then of course you want to do a coverage acceptance test on the system. That's typically done when you have in-building penetration requirements. That's typically done by testing outside as opposed to going into every specific building, since that really isn't practical. But you can do the testing outside by using a attenuator or simulating the in-building signal level or design margin as you do your outside testing. And then also we would recommend for those limited number of must-cover buildings that you actually test those specifically to ensure that they have the coverage needed. So those are the recommendations we have for our viewers, Rick.
So just to follow up on that, Dom, obviously building a new radio site is not always the most cost-effective or even required approach to providing in building. So Televate and the industry really focus on bidirectional amplifiers and distributive antenna systems for public safety. Is that something that you would recommend be investigated, say prior to even building a new radio site?
Yes, absolutely. As we mentioned, that is a trade-off as to whether or not you want to increase the number of sites in your new system or be able to provide in-building coverage through supplemental systems, such as an in-building system or distributed antenna system. Those are things you can research beforehand to understand how many buildings you may have to deal with. And then you can do a trade-off as to how much that might cost versus implementing a new site and how much that would cost as well.
Thank you, Dom. Very good insight and information for public safety operators and end users. And I want to thank you for taking time to share with our audience, and also take this time to thank our audience. Please feel free to provide your feedback, questions, and your ideas for future topics. And please subscribe to Televate Tech Talk at our YouTube page. And thank you for attending, and we look forward to sharing some additional knowledge about public safety communications with you in the future. So thank you.
Thanks, everyone.